Good morning. Today we are going to discuss the topic about Kirchoff's law. First, we know that what is meant by circuit. An electric circuit is a closed continuous path that allows electric current to flow from a power source through various components and back to the source. The next one is what is meant by node. A node is an electric circuit is any point, junction or segment of wire where two or more circuit elements, that means such as resistors, capacitors or sources, connect. It acts as a common connection point, and all points connected by wire with negligible resistance constitute a single node. The next one is branch. Any portion of a electrical circuit located between two nodes that contains a single element through which current flows. A circuit element between the two nodes. What is meant by loop means any closed path that starts at a node, transfers through circuit elements and returns to the same starting node without passing through any node more than one. That is a collection of branches that forms a closed path returning to the same node without going through any other nodes or branch twice. Now we can see the what is meant by Kirchhoff's law. Kirchhoff's law can be classified into two types. One is Kirchhoff's voltage law, next one is Kirchhoff's current law. First, we can discuss what is meant by Kirchhoff's voltage law. The algebraic sum of all voltages around any closed loop in a circuit is zero. That is summation of V equal to 0. It signifies that the sum of voltage drops across components equals to the total voltage supplied. KVL is essential for calculating unknown currents and voltages. Next, the circuit analysis. See here, KVL applies to any closed path in a circuit starting and ending at the same node. When tracing a loop, voltage gains are typically treated as positive and drops as negative. A common approach is that passing through a component from positive to negative. Using the Ohm's law, the voltage drop across a resistor is V equal to IR. See here the example, VAB equal to current into 7 ohm and VBC equal to plus or minus 3 ohm. Next, here applying VAB plus VBC minus 12 volt equal to 0. Substitute the values and solve this equation. We getting the current values 1.2. Next, the series connection. In series connection, see the circuit diagram. Current 10 ohm minus 12 volt equal to 0. Already we find the current value, that is I equal to 1.2. Next, the Kirchhoff's current law. Definition is the algebraic sum of all currents entering and leaving a node must equal 0. That is current I equal to 0. It is based on the conservation of charge, meaning the total current entering a junction equals the total current leaving it. Next, the parallel resistor. The total current entering a junction in a parallel circuit equals the sum of currents leaving it, as total current splits into branch currents. See here, I total equal to I1 plus I2 plus etc. IN. That is, in parallel, voltage is identical across component. Which branch carries are calculated using the Ohm's law, I equal to V by R. Then the equivalent resistance for any number of resistor in parallel R equivalent equal to 1 by R plus 1 by R2 plus etc. 1 by Rn. Finally, for two parallel resistors R equivalent equal to R1 into R2 divided by R1 plus R2. Thank you.